Okay, can you hear me now? Good afternoon, everybody. Thank you for joining us. Today is a special moment, I would say, because we are starting a new chapter in MRC's uh, activities, MOU with a foreign university, uh, also a visit by faculty from that university, and we although had a MOU with a foreign think tank with Bridge Tank in Paris, but now Strathclyde University of Glasgow has come forward, and I would give all the credit to Dr. Chaitanya Patil, who has come all the way to meet us here and discuss various aspects of our collaboration. Uh, I just want to take a couple of minutes to update you with what we have been doing and some positive updates definitely for you. Recently, we got the Scientific and Industrial Research Organization approval. So it makes us eligible for all kinds of research support from the Government of India, including any tax exemption or import duties, plus various other kinds of funding support and all other kinds of support by the Government of India. There is also now a possibility of MRC working with the Ministry of External Affairs to start a center of excellence for the entire Indian Ocean region. And also there is a global entity which wants us to work on capacity building for the entire global south. So that's another important development that we have. But our internal team has been working irrespective of whether we have a project or not. And now we are very proud to say that we have the complete marine spatial planning framework that is ready with us. And we are now populating this on multiple applications. So with that, I think I will end I don't want to take too much time. Probably at the end, I will come in. I also want to let you know, along with Dr. Chaitanya Patil, I also have Captain Sudhir Subedar, sir, who has been in the maritime domain for a very long time. Apart from being a shippy for a long time, but he has also served in the International Maritime Organization for a very long period. He's been part of global policy making at the UN level, and also been guiding us for a long time and giving us a lot of positive inputs to drive whatever. As you know, the UDA framework that we are working on drives various dimensions, and maritime is also one of the very critical dimension to it. And we thank sir for being very, very positive and always helping us in driving that part. So sir will also give you a little more inputs on, he has connections when he was part of IMO. He has worked with Strathclyde University. So I thought it would be appropriate to request sir, and he was very kind to say yes on a phone call. And sir has come today, and he will also give you some more inputs. And as usual, Prafulji is here with me, and he's our advisor, Blue Economy, always guiding us and supporting us. And we also have two special guests. Raj sir is here, and Malini is also here. So thank you very much, and it makes our team much more. We get a lot of encouragement when we see people, and I can see some new faces also. And there are people who have joined us online. Thank you all for joining us. So I'll not take too much time. I will hand over to Dr. Chaitanya Patil. Dr. Patil, I will also request you to introduce yourself in more details. I don't want to kind of give, and that gives you a freedom to tell us what you would like us to know. So over to you.
So that's the camera. Okay. So I'll have to stand here, right? Okay. So I'll go back again. Hello, everyone. Thank you so much, Dr. Das, for inviting me and letting me this opportunity to present myself, my work, about my department where I work, and talk about our partnership and our plans for the future, considering the underwater domain awareness framework and the maritime transport research from the Department of Naval Architecture, Ocean and Marine Engineering from the University of Strathclyde. Today, I will talk about certain aspects. So the agenda will be, I will introduce myself, my department, where I work, what are our research topics, followed by certain motivation behind this lecture and the partnerships, followed by some research areas that needs attention from the young generation specifically, focusing on the maritime and the UDA framework. Later, I will talk about certain relevant projects that have been done, a successful project from University of Strathclyde regarding the maritime transportation and UDA. And lastly, some expectations and the summary of the whole lecture. So, talking about me, my name is Dr. Chaitanya Patil. Currently, I'm working as a lecturer at Architecture, Ocean and Marine Engineering Department at University of Strathclyde, which is located in Glasgow. My research topic at this department are focusing on marine system intelligence and the digitalization of the marine industry. So my department, the Naval Architecture and this is basically the graph of my career where I started my BTech from India, from VJTI. It's a very well-known college from the Mumbai. After that, I worked for Tata Motors for a year, and then I moved to Europe to do my master's. So I did my first master's in France in automotive engineering. And also after that, I did my second master's in Spain, focusing on the combustion engines which are useful for transportation of automotives, ships. Then after that, that drove me more interest to do my PhD in combustion engines at the very well-known lab called Combustion Motores Térmicos in Spain. After that, I got some industrial experience working with a very well-known automotive manufacturing company from Japan called Nissan Motors, where I've developed advanced machine learning based models for calibration of cars, the hybrid cars mostly from Nissan Motors. Then after that, somehow corporate world pushed me go back to academia. Then I went to UK and started my academic career again fresh from the start at University of Strathclyde in marine engineering. So this is how I moved from automotive industry to marine industry when I came to UK.
People are just joining us.
Okay, yeah, sure, please. It's okay, it's okay. So at University of Strathclyde, I did many projects with the well-known institutions like the Alan Turing Institute, which is very well-known institute it's a national institute of United Kingdom who works on machine learning and artificial intelligence. It's okay.
I'll just take us 1 minute to think.
Sure.
This event is today our collaboration with Strathclyde University, Glasgow. We have just signed an MOU recently with them, and Dr. Patil has come all the way from there to interact with us, and so he's also going to talk about himself and his institution and what they expect from this collaboration and how we plan to go forward.
It does like it never seems it's so funny. You know, like just that.
वो भी बंद कर दो. Okay. Anyway, it's fine. Thank you.
Yeah.
So the Naval Architecture, Ocean and Marine Engineering Department, it goes a long way in the history. So I think from 1983, this is a very old department. Before it was in the University of Glasgow, and later stage when the University of Strathclyde happened, these two departments merged together and they found a new naval architecture, ocean and marine engineering department all together in the heart of the university, the city called Glasgow. And here you can see that this Henry Dyer building, which is basically the main building of naval architecture, ocean and marine engineering department, we call it a Naomi department, is located at the center of the Strathclyde University, where I work, where my office is. This department is first naval architecture chair established in 1983. It's the largest department and it's kind of in the UK and the Western Europe. And I'm proud to say that we are rated #1 in Europe and third in the world for marine and ocean engineering from the Shanghai University ranking. We have a center of excellence in marine technology in UK and beyond. We have a highly international, I would say mostly we have all the academics all across the world from South Korea, Japan, India, China, USA, and Europe working with us at this Naomi department. We can say that our annual research spend from 2012 to 17 is almost like 1.5 million pounds. So it's very well known department in the field of marine engineering, naval architecture, and ocean engineering. We have almost 16 professors, 4 readers, 4 senior lecturers, 3 lecturers, 5 technical staff, and 6 administrative staff working tirelessly all over the year. And we have a student community with 150 researchers and PhD students working with 70 postgraduate students and 320 undergraduate students for bachelors of engineering in naval architecture, ocean engineering, and marine engineering. We offer different post-graduation courses. Here we can see that at MSc in Advanced Naval Architecture, MSc in Offshore Wind Energy, Marine Engineering, Offshore Floating Systems, Ships and Offshore Structures, Subsea and Pipeline Engineering, Technical Ship Management. We also have courses in Sustainable Engineering for Marine Technology and Sustainable Engineering for Offshore Renewable Energy. And also we have Marine Engineering with specialization in autonomous marine vehicles, which is kind of a very well-known course these days, focusing on the autonomous marine vehicles. So yeah, let's talk about the motivation behind today's lecture and the partnership stemmed from this Maritime Research Center and the University of Strathclyde. We all know that COP21 happened in Paris with focus with United Nations Framework Convention on Climate Change. There is another COP26 happened in Glasgow City, where our Prime Minister announced the Panchamrit, the 5 Nectar Elements declarations, focusing on the climate change to achieve our climate change challenges. And recently, we have a G20 summit in New Delhi, where we have a declaration to unite the global community under the one umbrella called One Earth, One Family, and One Future. So we have all these global initiatives happening all over the world, focusing on the climate change and building the economy and building the whole community or the whole earth as one family. As we look at India, we have a so much huge coastal line, and we are the leader in the Indian Ocean region. So that's what I would like to highlight here, that India has a potential and resources available in our oceans and also the inland water, which will be helpful to build our economy. So that brings us to this slide, which represents all these ocean resources that we have, be it like minerals, metals, the renewable energy coming from the tides and the wind. We need to identify these resources. We need to understand them well. We need to explore these oceans and exploit these resources to build our economy that will create the jobs for the young generations, that will create different job markets, and that will sustain our maritime transportation and whole other industry all over the world. So we call it a blue economy, which is very important And governments are also working from different countries, like be it the Indonesian government, which was the responsible for before India in the G20. They have also announced their blue economy policy, which are focused on understanding exploration and exploitation of the sea resources. And also the Indian government is also looking on the same path. Second thing, we know that there is a fourth industrial revolution going all over the world, which is focusing on the intelligent digital system, which are powered by the artificial intelligence and machine learning. So it's the fourth industrial revolution, which is focusing on this smart machines and digitalization of the industry, which leads to productivity and sustainability of different industries. And if you combine both of these, blue economy and the fourth industrial revolution, which call for intelligent or smart marine system, which are quite essential and will be the focus of our discussion today. And when I talk about the marine system, that includes the underwater systems, the surface systems, and also the aerial systems related to ocean, which handle the resources from the oceans. So moving forward with this intelligent or smart marine system, the one thing that comes into mind, and which is also a focus of my research, is the marine system intelligence. So we want our system, we want our machines to be more intelligent. So we need research and attention of the researchers all over the world, and also the young generation, to focus their interest towards this marine system intelligence. And this can be done over three fronts. First one is the perception of these machines. Second one is the cognition. And lastly, the decision-making ability of these machines. Focusing on the first one, which is the perception. When we talk about the perception of these machines, we talk about the situation awareness capability of these machines. This machine should know the environment around them, and this can be done through data collection. So for example, for us, the perceiving ability of a human around there is like through their senses. We have touch, we have nose, we have taste, we have our eyes. Through these different sensors, we collect the data, right? So this is a perceiving ability of humans. So we need this ability well developed in our machines. So this is one front that we should be working on the perception of these marine systems. Next thing goes to the cognition. Now we have all this data collected through our sensors. Now we need to analyze this data and process this data. This can be done through the cognition abilities of these machines, where we have data analysis algorithm, which use different new statistical modeling, machine learning techniques, or the artificial techniques, artificial intelligence techniques to analyze, process this data and predict the parameters in the future, or predict the states of these machines according to the environment around them. And now that we have this analyzed data and the prediction variables from them, we need to take some decisions based on the application of these different machines. So we have the analysis, we have some predictions of the future parameters. Accordingly, we can take some decisions based on this data analysis. So these are the four fronts that requires attention of the young generation to work in marine system. So let's focus on the first forefront aspect is perception, which includes data collection and monitoring. So now it includes the collection of data, and I would like to classify this collection of data into two segments. One is the primary data and another one is the secondary data. The primary data focuses on existing sensor-based framework. We require to develop a proper structured framework with existing sensors so that we can collect the data be it from the oceans, be it from the rivers, be it from the environment around these machines in the maritime sector. So we need a proper framework to collect this data, and the data should be trustworthy, the data should be clean, and data should be accurate and precise. Next thing comes is we need research under that new sensor development. Of course, there are some existing sensors, but we need more sensors so that the perceiving abilities of this machine should be enhanced. So we need some more attention and research in new sensor development areas for marine systems. And lastly, the sensor fusion, which is a new technique that can be used to fuse data from different sensors. For example, we have different sensors like temperature, pressure, we have LiDARs, we have GPS. This data we are collecting, but every sensor has some limitations. For example, the LiDAR sensors is not capable for long ranges. Sometimes it won't be available for long ranges underwater. Then we can use ultrasonic sensors underwater. For example, we have to make some object detection task. We can collect this data from different sensors, fuse this data together, and enhance the capability, the perceiving capability of these machines to make certain decisions. So, be it the existing sensor or the new sensor development, we can use the existing sensor, fuse the data coming from these sensors to develop the perceiving ability of our machines. Next thing is the secondary data or a synthetic data. Sometimes we are not able to measure the data or collect the data from the field. In that case, we can use some digital twins and create synthetic data. I will talk about this in later phase, but that this data collection is really essential and the initial part should be there for our research for marine systems. Moving forward to the cognition, which consists the data analysis algorithm. So that we have collected data. Now we have to use this data to make sense of it. So we can create a digital twin, which is basically a replica of the marine system. For example, an engine which propels the ship or the heat exchanger. We have actual physical system. We can make the digital replica using the domain knowledge, the physics-based model or a data-driven model. And we can create the digital replica to create the synthetic data when we don't have a availability of the actual data collection. So the digital twins can be classified into two. One is a physics-based digital twin, which requires a domain knowledge, for example, thermodynamics or physics principle to characterize the systems. And then we can generate data with different scenarios in the environment. And the next one is a data-driven digital twin, which doesn't require the domain knowledge fully, but we can collect the data and train our regression model or classification model to predict the parameters, which are called data-driven digital twins. Sometimes we can use both a hybrid digital twin, which is a mixture of both physics-based digital twins and the data-driven digital twins. It depends on what is your application, because physics-based digital twin actually take a lot of time for computation, be it 2D or 3D computation. It takes a lot of time, while data-driven digital twin can do your task with less computational power, less computational cost, with higher accuracy. But only problem is it requires data for the training. So we can work on this digital twin on these two forefronts. The cognition also includes the performance prediction as the main task, where we try to predict the performance of our machines. For example, an engine, you want to predict the fuel consumption of the engine, the torque provided by the engine, or the power which is available to drive or to propel our ship in the seas. We need a prediction. We can do that through the collection of data, measurement, and then we can create some machine learning based model to predict the future parameters. Next thing, we can perform the health assessment of our machines using these different techniques. For example, fault diagnosis. If we have some data collected from our sensors, we can analyze this data and can predict the health of our system, how easily it can get degraded, or if there any fault appeared in any part or subsystem of our machinery, we can easily able to detect it. I will provide you relevant projects done at University of Strathclyde related to these aspects in the later part of this presentation. And also, yeah, degradation of this machine. By collection of this long-term data or historical data, we can actually predict the degradation happening in these machines throughout their lifespan. And we can say that this X machine has a lifespan of this many years, and after this, it needs a replacement, so that it can give you a proper decision-making ability for maintenance and planning. And lastly, the design of this system. We can use these days a generative AI, it's generative artificial intelligence, where we can train our agent-based model, which are generative models, which can give you optimized designs for your ships or your machinery based on the data you have collected so far. So these are the three different forefronts in my opinion, which are helpful for cognition of our machineries or the marine systems. Lastly, the decision-making ability of this machinery or decision-making ability of these systems. We need some algorithms in this field. Now we have the collection of data. We made some analysis data. We have predictions. We have health assessment analysis. We have a degradation analysis. Now we can. The machine should be able to make decisions in real time, also off time, which is like offshore decisions. So machine should be able to make decisions based on this collected data and the prediction and act accordingly. And also there is another option, which is offshore decisions, where we collect the historical data and analyze it not in real time, but offshore, in later stage, and accordingly plan the future decisions. What decisions are we talking about? So decisions related to optimization of the resources, the operation, the planning, and maintenance. For example, your ship has various power generation plants, which are may it be electrical power generation, like batteries, or a diesel power generation through combustion engines, or a fuel cells, and we need to optimize the power coming from all these resources in real time. So our intelligent machines can collect this data and analyze it and accordingly switch the power between these different power generation devices, so that in the overall voyage, we can save power and we can make our voyage efficiently with minimum requirement of our power. Next thing is the operation. We need our operation to be efficient. So decision related to the efficient operations of our systems can be done by our system themselves. Next thing is the planning. We can plan based on the health assessment analysis. We know that certain part or certain subsystem is going to fail, or there are some faults that have been detected based on our data analysis. And the machines or that particular subsystem requires maintenance that can be done through this planning, and this machine should be able to do this on their own. That increases their autonomy level. And lastly, based on this analysis and based on this fault diagnosis, we can carry out some maintenance activities so that it can increase the lifespan of our machines. So we need our machines to be more intelligent to take these decisions on their own instead of people doing them for themselves. So these were different forefronts where the intelligent machinery or intelligent system need more attention. From our university point of view, we have been doing a lot of work in this regard. I have curated certain projects for you guys to explain how these different routes or forefronts that I explained: perception, cognition, and the decision-making ability of intelligent machines through the different projects. So there is, thank you. The first project talks about, sorry? You mean the dialog box? It's okay, leave it. So let me talk about this project, which is basically data-driven twin of an engine which predicts the in-cylinder pressure using only engine speed and engine power. This was a project which we have done with funding from the UKRI in partnership with the Datum Electronics and the Alan Turing Institute, which is the National Artificial Intelligence Institute in United Kingdom. It's UK Research and Innovation. It's a funding body. Yeah. So basically, this project focused on prediction of in-cylinder pressure signal using engine speed and engine power as an input. Please come in here. I don't know if you can see here, as I was the secondary data from the perception point of view. Here we have used a thermodynamic digital twin, which basically replicates the digital diesel combustion engine. And we have generated different data points on different operating parameters from this engine to create the synthetic database, which database then used to train a specific artificial neural networks to predict the in-cylinder pressure for all 9 cylinders of the diesel engine. For this, we use a dimensional reduction techniques using Fourier transform and also another technique called log signatures, which was proposed by mathematicians at Alan Turing Institute, which is used to reduce the dimensionality of the data. That means the pressure signals, because we have 720 degrees of dimensions for a pressure angle, the crankshaft angle, which gives you the in-cylinder pressure profile for 9 cylinders. So that means 720 multiplied by 9. But that much data points will take a lot of time to train our neural network. So instead of that, we use the Fourier signatures or the log signatures, which are path signatures, which is a theory proposed by a scientist from Oxford University, which is also working with Alan Turing Institute. So with the application of this method, we can reduce the dimension of this 720 multiplied by 9 cylinders to certain path signatures, only 10 to 15 points. So with this dimensionality reduction techniques, we can train our artificial neural networks within minimum amount of time. It's like 1 or 2 minutes for one. And then this trained artificial neural network can be deployed on the ships on board, which doesn't require any software or any tool, which is just a basic Python code, which you can deploy for like 20 MBs max. And you just have to provide the engine speed and engine power as input, and that will give you the in-cylinder pressure profiles for all 9 cylinders of this diesel engine on board, so that the engineer on board can decide what is the current operating point. So this is an example of a data-driven digital twin that we can use without any domain knowledge of the combustion. So the engineers on board can utilize this kind of model with less amount of computation power and with higher accuracy. Here you can see that these are the different prediction results from different models, where the black line represents the actual measurements on the ship, on board ship from the P&O ferries, and the green line represent the prediction from another method, which includes on engine speed, power, and angle, while the red line represents the input as engine speed and engine power, where you can see that the error on the right hand side can be seen. It's between -2 and 2%. So the error has been reduced a lot. That means this particular technique works very well, providing you accurate in-cylinder pressure measurement prediction on board vehicle or on board the vessel without any domain knowledge or technical expertise. Next project is related to the health assessment of this machinery, focusing on the fault diagnosis. This was also another project was funded by the UKRI, the United Kingdom Research Innovation Funding Body. We have created a new sensor, which is a sensor development project in partnership with Datum Electronics and P&O Ferries, where we implemented this instantaneous torque sensor for the shafts of the machinery or the engine, which measures the instantaneous torque for collecting 2000 samples per second. So that's the sampling rate of this sensor. And with this torque signal, we can identify if there is a fault in an engine or not. And where exactly is the fault happening, we can identify only using this torque signal. The idea behind this can be explained with this methodology, Here on the top left side, you can see the instantaneous torque measurement sensor, which was deployed on board ship. I was also in charge of this of deployment. I myself went on the ship and see through how they installed this sensor, which was developed specifically for this task, which records the torque at the shaft level for collecting 2000 samples per second. Then this torque signal can be used to predict the in-cylinder pressure profiles using the crankshaft digital twins, which takes into account the lobes and the masses and the inertia of the shaft. And this real-time in-cylinder pressure is compared with the actual in-cylinder pressure measurement or predictions, which can be provided by the thermodynamic digital twin, as I explained before, or we can use the actual neural network, which was trained from the previous project with less computational power. And the new algorithm that we have developed can compare these two cylinder pressure profiles, the actual ones from the measurement through this torque sensor and the one which was predicted by the neural network, and give you if there is a fault or not. This was done. And now, as you know that this is the strategy or the flow chart of the algorithm that we have developed to identify the faults. But now to train this algorithm, we need some faulty data. Obviously, we need a data where actual faults appeared. But it was not easy to go on a ship and break the injector or break the shaft or maybe break the piston and do the measurement so that we can train our models. And in future, if this incident or this fault occurs, torque signal will notify you beforehand that this particular fault is going to happen. So for that, we have used digital twins where we actually induce some faults. So here you can see that we have injected some fault from injection point of view, the blow-by fault where we have some wear and tear of the ball. So in compression stroke or in the combustion chamber, if there is a leakage of the exhaust gases, that reduces the power of the engine. So that fault can be identified by as a blow-by loss. Then there is a friction fault due to the wear and tear of the piston. The movement of this piston inside the combustion chamber restricted. That's why it increases the power and increases the fuel consumption. And lastly, the charge cooler fault, where we have a fouling of this cooler due to damage or the impurities in the water which was used to cool, which changes the operating point of the engine and affects the performance of the engine. So these different faults were injected on each level. For example, this is the blow-by fault where you can see that the gases were leaked out from the combustion chamber. We have the friction fault. And lastly, the charge air cooler where we have a fouling of this cooler which changes the operating point. So we carried out different simulations with different degrees of the faults. So here on the right hand side, you can see the beta value, which is nothing but the fault index or severity of the fault. So we went from 0, which is like completely healthy, that means no fault, to 0.6, that means like worst condition. And we trained our neural network model to predict this fault intensities. Here you can see that the inputs for this model are engine speed and engine power to estimate the in-cylinder pressure from the previous model, and the pressure profile measured on board dynamically reduced using the log signatures or the Fourier transform to this model, which takes into account this initial information and gives out the beta values for different faults. So if you have a start of the injection fault, maybe your injection is damaged or it's getting delayed due to some impurities or certain damage, this beta severity will be predicted in real time before the actual devastating fault can appear. So this is kind of a health assessment. This kind of algorithms on board ship can provide you the health state of your system. For example, there is a fault in your subsystem, there is a fault in your friction, there is a fault in your piston, there is a fouling in your air cooler, this can be notified beforehand the catastrophic failure on board the ship. If you see, here are the results. I don't know if you can see because of the light, but on the left hand side, you have the beta of blow by, the fault intensity due to blow by, the accuracy on the y-axis, and different models that we have used to predict this fault intensity. And you can see that if the accuracy or R square value is closer to 1, that means the model is really nice and it's predicting accurately. So for the blow by and the cooler fault, you can see the accuracy of these two models. Anyway, so for the blow by, the accuracy for different models lies between 0.9 to 1. So fairly all models perform very well, where you can see that the polynomial regression has the highest accuracy. In case of cooler, the accuracy is not really high except the polynomial regression. This is because you see the input for your model is engine speed, power, and the in-cylinder pressure signal. So this cooler fault is not related directly to the combustion chamber. And this fault lies outside of combustion chamber. That's why we don't have enough information as an input for our model, which leads to reduction of the accuracy for that particular fault. But if you go to the next slide, the fault which are directly connected to the combustion chamber, like the fault in the injection or the fault in the friction of the piston, the accuracy is fairly high. It's between 0.9 to 1 for both of these fault intensities. So the more relevant information you provide to this model, to the different variables, to collection of data from the sensors, the more accurate these models will be, and the more accurate or precise intimation of upcoming fault will be received on board vehicle in real time. So this was another project was done, which was focused on the cognition of this worried system, where the collected data or the predicted data can be used to assess the health of the machinery. Lastly, this is more related to the underwater side of the research at our department, which focuses on the sensor fusion. So this project is, okay, now the dialog box is hiding everything. So this project focuses on the underwater object detection. So the aim of this project is to develop a sensor enclosed with different sensors with different capabilities like video cameras, sonar, LiDAR, or temperature sensors, which are deployed underwater on a particular vehicle, which can identify different objects below the water surface level. As we know that different sensors have different limitations, video cameras won't provide the accurate and precise data underwater. And if there is no light available underwater, video camera won't even work. In that case, we can use the sonar data, the ultrasonic sensors, to identify this different object. But in that case, we won't be able to get the high definition. So that's why we can use these all sensors together and fuse their data all together to this neural network. And here, particularly in this case, we use a neuromorphic fusion network. These networks, although we know that artificial neural network actually imitate the human brain neurons, but that's not the case. The artificial neural networks, they only have the analog signals. So here you can see that on the left hand, they receive the input as analog and get nodes with some activation function and gives you output, which is another analog signal. But we are using a spiking neural networks, which are more closer to the neurons we have in our brains. Okay, so in our brains, we have the electric signals, which has traveled through these neurons from one neuron to next neuron. So these kind of spiking neural networks actually imitate the neurons in our brains, and they don't provide the input as analog signal, but the spikes of electric current, or in our case, the binary spikes are provided as input with some activation function and gives you the frequential spikes at the output end of the neural network. Why? The advantage of this is they are more accurate, they are really good at handling, and they're quite fast. compared to the traditional neural network, which we call them as artificial neural networks. So we try to use this neuromorphic uh, spiking neural networks to analyze the data collected from this different sensor, fuse it together, and give you the output, which object is in front of you. The advantage of this kind of system is that you can carry out the monitoring below the water surface. You can measure the meteorological aspects. You can measure certain bodies in underwater. We can carry out some inspections for the pipelines or any system we have underwater or in the seabed, like our mining systems. This kind of sensor fusion algorithm implemented with different sensor data can actually identify the faults below the water surface. If there is a fault, they can do some inspection and provide you the data in real time if there is a fault or not, or what is the current state of our system which is below the water. And it can also give you, there was another project we have done with another SME in Europe, which use the similar algorithm on their autonomous buoys, which are deployed to save the man overboard in the sea. So basically, these buoys will sense if there is a man overboard, whose man is drowning in the sea or a river, they can sense it, they go over there, identify if the body is dead or not, if it's a human or if not human, and if it is a human who needs help, it can go there, collect the human and come back. So this operation is performed totally autonomously by these buoys. So this kind of these algorithms have application in this kind of system where our machines, the marine system, can become more autonomous and accurate, so that we don't have to rely on certain delays due happened by the humans. There is another project we have just finished with the European Union, which was focused on the autonomous ships, where we were working on the ships who can travel autonomously through the sea from point A to point B, which was done with various organizations from Norway, Italy, Greece, UK, and France, where we actually performed the experiments on a ferry, which was worked autonomously. And also, we tried to work on the legal aspects of these autonomous vehicles. What should be the regulations? Because as you go from a manned vehicle to autonomous vehicle, you need to take into consideration what will be the legal aspects and the consequences of these autonomous vehicles. So that project took into consideration also the legal aspect, different regulations, the norms that should be in place when we actually try to produce these autonomous vehicles or autonomous ships or underwater vehicles in mass production. Apart from these big projects, which I mentioned before, we have some individual projects for our master students. We have over here, like development of an onboard automated planning and maintenance systems using ML algorithm, like again hybrid system design and optimization, the hydrodynamic analysis of a semi-submersible platform, the data analysis for ship energy efficiency. Then we have another project focusing on CFD analysis. Some structural health monitoring was also a part of the project from the ocean energy unit. The investigation of safety culture assessment methods, the FEM, the finite element modeling of a collision and grounding of ship, decision support, focusing on the last aspect, the decision support mechanism for end of life scenarios for offshore wind farms, hydrogen and fuel cell research, numerical study of water and vapor multi-phase flow, and lastly the aerobic assessment of the frigate using the computational fluid dynamics. These are certain, not I tried to mention the most important and relevant projects here from the master's students. We also have some group projects that you might be interested in, like offshore hydrodynamics, hydrogen generation and transportation project. We also had a design of Stratclad ocean cleaner machine, a sea cleaning spider, a design of a floating bin, a design of an autonomous underwater cleaner was also another project was done by some group of master students at our department. Then we also have a solar energy and fuel cell assisting the auxiliary engines on board the ships. Then we had design and management of newly built LNG fuel tanker, methanol and alternative fuel for the engines to reduce the carbon footprint, design of a retrofitting dual fuel engines which can cruise in the cruise sector, and lastly the green powered vessel, a hybrid propulsion system. So you see that these are all advanced projects that our master student doing at our department, focused on the advanced technology, focusing on the marine system and the research. We also have industrial environment from Marine and Ocean Forum. We organize seminars and guest lecture for our students from the industrial, the professional executives from the industry. We have some assessment for the group projects and as well as the individual projects. We have represented in the Scottish branches, and we have RENA and IMRS, and all our courses, both our bachelor's and master's courses are certified by IMRS and Royal RENA. And also for our students, bachelor's and master's students, we have a Marine Career Fair early in February for their job placement after their studies. So we have a very good connection to the industrial network all over the Europe. From the experimental point of view, for this research that we have been doing, we have a rich experimental facility available at our university department. From ship motion simulator, we have a Kelvin hydrodynamics laboratory where we have a toy tank to test different ship models. We have a turbulent flow channel to analyze the different turbulent flow over the plates. We have a marine engineering laboratory to test and design different small scale robotics projects that I'll mention later. We also have our own yacht called Catalina, where we can lend this to students to perform some experiments, obviously with certain supervision from the safety point of view. And we can also do some field measurement equipment which we can provide students to go on boats. We have just prepared a new small ocean basin which has a transparent wall to carry out certain underwater measurement using different sensors, like the project I mentioned for object detection for underwater bodies. We have different sensors mounted in this basin to carry out some data collection for underwater measurement by changing different scenarios like environment, for example, changing the temperature of the water, salinity of the water, and see the impact or the effect of these different changes in the environmental parameters on our data collection, and finally the output of our algorithm. We also have a virtual reality lab which we provide, where we provide different trainings to our students. For example, the onboard ship or the engine room trainings, so that they can have a real life feelings or experience through VR labs. And also we are certain projects where we try to output the results of our machine learning algorithms or the artificial intelligence based algorithms to display the output through these VR goggles, so that the person won't have to reach to the computer and see the results, but he can see in real time what are the effects and the consequences on board the vessel or on board the ship based on the health assessment or fault diagnosis or the performance prediction. We also have created a marine robotics society for the students, where our students can actually develop their own small scale craft. So here I have mentioned a small craft, catamaran craft, designed, manufactured, prototype solely by our student, and they entered into in the competition also, where these crafts have an ability to navigate autonomously themselves, avoiding some obstacles. Now they are working on some underwater vehicles which can move or navigate autonomously, avoiding some obstacles underwater based on the algorithm provided in Arduino or a Raspberry Pi on board this small scale craft solely designed by the students. So this is the way our student can learn the, these new concepts, the new data analytics ability, algorithms, and they can implement them on board on the prototype and see the results. So that way they learn better through this problem-based learning, and they understand it better. So after this long lecture, might be boring, the summary or the takes that I would like you to take is the blue economy and the fourth industrial revolution calls for the intelligent marine system. We need attention of researchers or the young generations to develop this intelligent machinery or intelligent marine system, focusing on their perception, their cognition, and the decision-making ability with higher autonomy. The future of the maritime sector required digitalization because of the race and the advancement in this maritime sector. Digitalization is very necessary, and it should not be limited to only the merchant navy or the defense. The sector requires the people or the students from all sectors, not only marine engineering, not only naval architecture, but people from electronics, computer science, mechanical engineering. We need these people to work and come to work with us and do research, because this sector has a future. Underwater domain framework provided by MRC needs people from different diverse backgrounds so that they can come together, create this platform, take some initiatives and develop a new novel algorithms and novel machinery which can drive the progress of this new intelligence system and ultimately conserve the oceans, conserve the inland water system, and increase or develop the economies of our countries. Skill set. Obviously, we don't only need the domain knowledge of marine engineering and naval architecture. We need knowledge from data science. We need knowledge of machine learning. We have seen that this has been only the responsibilities of the computer science and electronics engineering and IT or triple E, that these people only do this kind of stuff. But I would say these people, they have already developed certain algorithms that we can see in our phones, that we can see in our TVs. We can see in Alexa, we can see in Google, Siri, but we can implement these algorithms on board ships, on the marine system, and we can improve them also. Instead of only developing our phones, we need to develop these systems which can actually provide a job market, which can actually develop the nation and provide the growth and provide the growth for blue economy everywhere in all over the nations. So data science, artificial intelligence, I would request, and I'll take opportunity of this platform to request all the students from different backgrounds to come and work with us, work with MRC, or you can work at the University of Strathclyde, do different courses, or you can do your PhD, whatever you want to do. And lastly, the collaboration, which is really important, I would say, because nowadays the engineering field is getting quite diverse. People should have knowledge from different backgrounds. So not only like civil engineer or mechanical engineer, also should know the knowledge from electronics. A civil engineer also should know the knowledge of, they should have a knowledge of machines. So a collaboration is the key in this case, like the way to a way forward. For example, the collaboration with Strathclyde and MRC is just one example. I would like to invite other organizations who are working in this area to come together and collaborate, irrespective of which nation, irrespective of which country are you from. This kind of collaboration will lead to the innovation and development of this particular field. Well, thank you so much for listening patiently for my lecture. If you have any questions, you can let me know.
Mentioned people here, and also we have senior faculty members from Patil College. But also there are people online who are encourage you to get the marine and the underwater domain more seriously. There are many opportunities within. And we are happy to serve as a platform which can be leveraged by you to make sure that you get connected to the right kind of people. And as Dr. Chaitanya also said, we are looking at joint internships, fellowships. You can be sitting and working here with us. We also have an exchange program, so we would also encourage and support some of our interns and fellows to travel to Clyde, and many of them will be also coming here. And some of the people who are new, they probably don't know. We get about 500 applications from IITs for internship. So you will also get an ecosystem where you can work with the best in the country and probably the best in the world. And this is a series of partnerships that MRC has started. I'm happy Dr. Chaitanya could travel all the way and spend some time next week. On 1st of December, we have somebody coming from Tokyo University and Jamstech. And that's another partnership which is going to start very soon. And I think this is a beginning of many more such partnerships. And I think all of you will understand, I mean, I say this more often, that 75% of this earth is water, right? And if you do not focus on water, and I think we are missing out. So, and both for freshwater and marine, there is a lot of things to be done. And if we don't participate, or at least, as academic institutions, if you do not expose your students to the right kind of opportunities, then I think we are missing out on something very important. I would also be very happy to announce that MRC has now been shortlisted by the Ministry of External Affairs to work on setting up a center of excellence for the entire Indian Ocean region. So that is, it is part of the IORA agenda, but it is starting with setting up a center which would be this center for India and supporting officials from all the 23 countries in the region. But that is the first step. The second step is we would be supporting them to start center of excellences in those countries. So I think it's a very big project and a very big responsibility given to us. But what I told them and what I firmly believe is we need a huge manpower to do this. I don't think we'll be able to do it all by ourselves. So we need many of you to come and participate. These kind of collaborations with, I mean, this kind of institutes and, SAGAR University, they have an experience of so many decades. These kind of partnerships help in for us also to mature our thinking and mature our various ideas. So I'm very excited, and I mean, I must thank Dr. Chaitanya for himself finding us, chasing us, and making this happen. Thank you very much. I really appreciate this. I mean, we were more than keen, to be honest, but you having taken that initiative, reaching out to us, we had a couple of meetings with him, then with his team and with his authorities, and we found that I think we are compatible. We value each other's contributions, and so we thought that it is a good way to move forward. So from that perspective, I'm very excited that whatever we have done over the last 4, 5 years, 7 years has come to a level where we are getting the recognition. The second good important announcement is there's a global body. I don't want to name it right away. They are equally keen to collaborate with us for the entire global South. I mean, Dr. Chaitanya started his presentation on G20 declaration, and now we are talking about human-centric development and a whole lot of things. So there again, there is a global partnership that is being discussed with us. UNESCO is going to be a partner to that on sustainable blue economic development and also climate change study. These are becoming very important areas, but they want to look at this in a more serious manner. They want to set up a center of excellence for supporting Africa, South Asia, and various other global South countries. So that will be another big project for us where we'll again need a lot of people, a lot of support. So that again becomes a very important area. And the third part there is marine spatial planning today has become, I mean, what Dr. Chaitanya mentioned about digital transformation. According to us, for the underwater domain awareness, marine spatial planning is become the de facto tool. So we at MRC are, I think, working on a very unique platform for building the marine spatial planning for the entire world. I'm saying something very big, I know, but I think we are very confident that we can drive, and I feel very confident that India has that capability, not just me. We are probably just one of the small drivers to it, but India as a country has the potential to drive this. And that strength comes to us because we have so many institutions at various levels. I mean, I personally, I have divided this into 3 levels. One is the top higher education institutions like IIT, which have built a reputation. But there are also many other institutions who can contribute to this. So one is at the very high end, uh, you know, policy level or high tech level where it has to be driven. The second is the domain expertise and people who will build this up over a period of time. And the third is the skilling level where for field experiments we are also reaching out to the communities, for the fishermen community, for the riverine communities, for the coastal community. Prafulji is here. We also have another organization together, which we call Maritime Culture Foundation. Basically, what we want to do is keep a fisherman's child within the same thing, give him better opportunities, but you should not take out a fisherman's child from the profession because that is equally important. So how they can get a better remuneration or get a better respect for. So this marine special planning, the field experimental or the waterfront field work will be done by these people. They get better. So the skilling becomes very important. So we will help in skilling them. We'll help in generating opportunities for them. But if India has to contribute this at a global level, you can imagine what kind of manpower are we talking about. And this is not just for India, but for the entire world. So these kind of partnerships also brings us, access to the larger global scenario. So that is the larger plan. And I think we are now feeling much more confident that, the global community is taking us seriously. When the Indian authorities are taking us seriously, I would request you to follow the various events that we do. Recently, we hosted the former Defense Secretary of India, and he has recently been taken into the Indo-US strategic partnership on maritime. And he did message me that Arnab, UTA is important for the Indo-US relation. India has maritime strategic partnership with 5 countries, US, France, UK, Japan, and Australia. So we think the UDA framework, today I didn't have enough time to tell you about UDA framework, but UDA framework is relevant to these maritime partnerships. So I think at the top level also, people are understanding the value of what the UDA is all about and what it can do. So we need a lot of support from all of you. We would like more participation. And I thank Dr. Chaitanya for coming all the way and initiating this partnership. We would definitely be very, very keen to contribute and support this partnership and taking it forward. We are working on multiple levels. We are trying to build a lot of things, and your expertise and your institutions' activities and expertise definitely contribute hugely to the underwater domain awareness framework that we are working on. And what we bring to the table, or the unique contribution that we bring, is the tropical conditions. I mean, the tropical characteristics are very different, and I don't think there is any institution globally which focuses on that. I don't want to say that we know it all, but we are learning. But we definitely have a very clear focus on that. And I think that's going to help the whole global community in multiple ways. And we have many projects. I mean, I think after we break this event, I would request all of you to spend a little time. My team is here, I'm here. We would like to explain the various projects that we are doing. Our website, we have a UDA Digest platform. Our MRC website has a section called the Knowledge section, and there you will see a lot of projects. Young people can just go take some ideas, and but they want to join us for internship fellowship, they can happily do that. Even when we do these joint things, they can also work with certain projects which we are going to be working together, and some of them can be part of those kind of projects also. So it's an open domain. So I think I will stop here. I would request Subedar sir to kindly come and give his views, because he is somebody who has been in this domain for a very long time. Sir, would you like to come here? The camera can see you then. So you can sit here and talk.
Good afternoon, ladies and gentlemen. My name is Sudhir Subedar. I'm an ex-seafarer and years of sailing and onshore experience. Thank you, Chaitanya, for elaborating on way forward with MRC. Yesterday, about this time, I was being interviewed by a YouTube channel in Dubai on coastal security. As you know, after 2008, this topic of coastal security has become a very big issue when somebody penetrated Indian borders from the sea. My angst is that our waterside domain is so large, almost 3 times more than the land size of the subcontinent. What I'm talking is the 200 miles of exclusive economic zone. The resources provided for that are dismally very, very low. There is SENA on the land, there is hardly any marine policing on the waterfront. Blue economy we have talked about or was mentioned in the previous speaker's presentation is all to do with the exploitation of the blue economy of these waters up to 200 miles of economic exclusive zone. The future lies provided resources are put in place for exploitation underwater. I'm struggling to bring UDA and MDA awareness within this merchant shipping fraternity. So that's one big task which MRC has to populate this idea of underwater domain awareness. And I've been telling Commander Das that one of the things that will happen, and through the presentation of Chaitanya, something that needs to be tangible to the merchant shipping. India's merchant shipping is so low that it doesn't make a difference in Delhi or the powers that be to deploy the necessary resources for this work. What Satellite University and Chaitanya's senior department officials, I have had an opportunity to work in early 90s. In particular, Professor Chengi Kuo, emeritus professor now, I believe, and one of the most distinguished naval architects awarded even by International Maritime Organization. Chengi Kuo at that time had stalwart kind of work, which was beyond recognition then. And now this new topics of advanced learning, artificial learning, machine learning, etc., are perhaps bumper to him, but he would be able to translate them or help the youngsters to translate that into reality. And that's where I think what we heard in the previous presentation is that academic work needs to be transformed into something tangible on upfront. For example, he mentioned about using UDA, and Commander Das has been working, is to make use of these sensors and these algorithms and these techniques to make quicker available dredging platforms, for example. We are rushing for time to make our rivers navigable. UDA technology needs to go forward, find solutions to make dredging happen. No point in having depth day after tomorrow. I need depth today. The demand for depth of the rivers in the navigable rivers of India is today. The navigation, radio navigation, which will take long time, perhaps can be helped by the kind of sensor underwater vehicle which could navigate ahead of the inland vessel to go from Varanasi to Guwahati without touching here and there. So by the time government comes in and others comes in and puts up platforms and radio stations, we'll have lost the game. So my advice to youngsters who are here, do come forward, collaborate with us, more on the applied application of that into tangible output that can come from various verticals that were shown in the previous presentation. I thank Dr. Chaitanya to have brought us up to speed with a quite phenomenal work that goes on, and everybody knows about Strathclyde University's. This department has been at the forefront for many, many years, at least since 1965. A lot of work has been done there, and I would be happy to continue collaborating and assisting Dr. Das on this particular work, and maybe come and see you sometime in Strathclyde. Thank you very much.
Hello, everyone. I'm so happy being here. Thank you so much, Dr. Chaitanya Patil. You are a role model for so many students in India. And I hope many more, a lot more, follow your path from automobile engineering to artificial intelligence. So there are so many paths now. The Industry 4.0 is happening very much. So like you said, all the disciplines can converge. It's interdisciplinary. Everyone can participate and contribute, right? So I just want to say that on the way here, coming to the venue, I was listening to the news and they were talking about the 2+2 dialogue between India and Australia, both our defense minister and the foreign minister of India and of Australia. And what was mentioned was the maritime collaboration between India and Australia and the blue economy. Both these terms were mentioned in the news. And that's exactly what we are trying to do here at the Maritime Research Center. I've been associated for the last, since inception. It's very, very satisfying to see what Commander Das has been able to achieve in the Maritime Research Center. It's really very heartening. Thank you very much, everyone, for your participation. And I see the Maritime Research Center really blossoming in the years ahead. Thank you so much. Thank you.
Would you like to say something about your impression on? I would also like you to introduce yourself.
Sure, definitely. Yeah.
I really value you joining us today. It's really important for you also to address.
Well, very good afternoon to you all. My name is Uday Desai. I am heading the next building mechanical training activities. I am from NTTF, Nettoor Technical Training Foundation, wherein we do a lot of training to the youth in the field of diploma in mechatronics and diploma in electronics. Mechatronics is the combination of electronics, mechanical, hydraulics, pneumatics, all put together. And then they do a lot of projects over here also in the final year. And in NTTF Bangalore, we have the post-graduations courses also and the post-graduation diploma courses also. And we have certain plans of developing the post-diploma courses over here in the same building, next building. Well, I understood a lot of things from Dr. Chaitanya. I didn't know anything about the underwater domain as such. But the thing is, our diploma candidates, is there any opportunity for those candidates? Because a lot of students who pass out from NTTF take up the higher education into different domains. So is there any opportunity for them to take up the higher education over there in underwater domain activities? Because they are experts, they are all trained in the fields of mechatronics. For the projects what I saw, the sensors and the other equipments which are being used to collect the data and then do the analysis of data, all those things are, they have been trained on that area in the beginning itself. So that will help them in taking up the higher education in that particular domain. So I would like to know more about the opportunities for that kind of candidates who can take up their career in their future activities. Thank you very much for inviting me, Commander Das, and it was a very useful information for me also, which I can pass on to my own people who are, undergoing training over there in NTTF in post-graduation as well as the graduation and diploma. Thank you one and all.
Thank you, sir. I think that is what is the idea, sir. I mean, locally, we have an institution here and we have collaboration with multiple such organizations. And they are also, I mean, the very fact that a university of that stature is looking at India, I think India looks good today. And so, I mean, sometimes I get worried that are we responding enough or not? So we are definitely here to facilitate that. As I mentioned, we are here to encourage a lot of internships, and some of them which is relevant to their work. Those students will also get an opportunity to work. They will even get certification, joint certification with their logo and their thing, because they will be, see, the point is that we want to minimize the logistic cost. Today, a lot of online work is possible. We do a lot of field work. They are also interested in having data access. But what I requested him, that exchange of data is probably not possible. But what we can do is some of their students can work from there and some of our students can work from here. Our students work here on the data. They can jointly work with their students. And similarly, there'll be data collection there, and our people can also, if they can travel here, they can definitely have access one-to-one. But otherwise, we will also have some of our, I mean, in India, we don't have shortage of people. So, but it will give a good learning experience for our students and their students also. And this will bring jointmanship on both the sides. Those students in their institutions, students in our institutions can work together and build these things. We will have some workshops between us and NTTF also, sir. I mean, we have just set up now. We are also, so we will definitely do that. We will tell you what all, today there was not enough time. I wanted to give him more time to speak about their work. But a lot of it, what Dr. Chaitanya said, we will support from our side also. And we will also be reaching out to Dr. Chaitanya and his other colleagues there to also give lectures online from there, and our people can attend from here. I mean, we'll do those kind of collaborations also. That's the whole idea of this thing. And wherever possible, even Dr. Chaitanya is looking at few joint fellowships. I mean, Indian British government have announced few fellowships, so he'll be writing some proposals. We will be together writing some proposals. So he will also spend more time in India with us. That's the whole purpose. And also there will be some joint projects that will be written for EU funding, and which can be jointly executed by the two organizations. We ourselves have a few projects with us now where we will be doing. So we will be also looking for support in terms of students and various other people. So I think it will be a very good thing. And I would again like to thank Dr. Chaitanya for taking this initiative. And I think, as I said, next week there will be somebody from Tokyo University, and I think this will only grow. And I'll be visiting few countries in the next few months, and there are some more collaborations that are on the thing. And we are going to be looking at partners in Africa and various other countries. So there also our model would be the same. We will be reaching out to their institutions so that their students can work in their projects, rather than we will definitely send some students for exposure, but the project execution will be done by their local people. And I want to be very clear about the data part, that their data remains with them and our data remains with us. So in that, we'll require enough people on both sides. And even from DY Patil also, any student wants to reach out, please do that. And I would request one of the faculty from DY Patil to come and speak.
Good afternoon. Myself, Professor Dr. Shiralkar. I am along with 5 of my faculty members, 5 of my students members over here from various disciplines to understand what is MRC. Earlier, one session was there with Arnav sir in DY Patil, DYP COE also. So what I have not served, sorry to say this, I have not served MRC website, but we would be interested in doing some joint projects with our students and whatever is the problem definition with you as a globe. What we would be expecting is what you are rightly saying, logistics is a big problem. So they can do online projects also, and they can work over here. And best is if there is any list from various projects, we can work on them, and we can have joint collaboration also. Thank you very much for speaking over here. Thanks a lot.
So I think this particular session is over, but all the visitors who have come from outside, my team is here. They would also show you some of the projects that we are doing and some of the resources that we have. My colleague Shreya is here, Ayush is here, and Jay is here, and they will show you some of the resources that we have. A lot of our resources are online, and I would be happy to tell you that 10 of our e-learning modules on different aspects of UDA have been uploaded in the government iGOT platform. So all the 30 million government officials in both in center and the states are going to be going through all of them. So it has just happened a week back, but we've been working on it for almost 6 months. But now that has been finally uploaded, so they will be aware now. So when I say job opportunities and whole lot of other things, when the policymakers are aware of what a new domain is, I think it gives us a much better kind of opportunity. And we will be hosting many such events where we will get a lot of senior people from these organizations, like secretaries at the Government of India, but even many of like inland water transport is a very big project. I mean, it's right now the budget allocation is about 10 lakh crores. Then SAGAR Mala is about 6 lakh crores. So we will be getting some senior people from those organizations also, to not only they should come and see what we are doing, but we can also kind of make them aware that how we can contribute to their thing. So these kind of dialogues and these kind of interactions will help us build opportunities for the next generation. I mean, that's what is our effort. And we will also have some foreign people also coming in, and because the problems in the entire Indian Ocean is the same. So I think India can take the lead, and our people can get opportunities and also provide them more knowledge and support. So thank you very much.